Okay, good morning, good afternoon. I'm talking about my article. It is about the electric vehicles. Okay, nowadays the number of vehicles in the world is increasing day by day, which leads to high oil consumption in the transportation sector. According to research, it is estimated that about 70% of oil consumption is consumed by the transportation sector, not to mention all the environmental damage that is generated as a result of this pollution, which is why I am interested in talking about an article entitled A Robust MPPT Approach Based on First Order Sliding Mode for Triple-Junction Photovoltaic Power System Powering Electric Vehicles. This article focuses on the development of alternatives to develop new energies useful for the transportation sector, based on this alternative. In the second section, the modeling of the system used is provided. In the third section, the MPPT algorithms used are presented and a comparison study with the conventional MPPT and O algorithm and three meta-heuristic algorithms is provided. Simulation results are presented and discussed in the fourth section. This section presents the conclusion and some futuristic prospective proposals. It is important to mention that when we talk about the MPPT, maximum power point tracking, it is understood as a charge controller that is used to regulate the amount of electrical energy that is supplied to a battery. So this article proposes a solution to this problem generated by conventional vehicles. Therefore, the electric vehicle in the transport sector seems to be the right solution if the electrical energy consumed is produced from different renewable energy sources such as photovoltaic, wind energy, biomass, geothermal energy, among others, which guarantee a good operation of the vehicle and in a parallel and environmental protection. Now, for the case of this article, it is the case of photovoltaic solar energy. Solar cells are used to transform the solar energy provided by the sun into electrical energy, being this a capable solution for the energy production of electric cars, thus managing to exploit this renewable energy. Grosso modo, the main objective is to explain what are the characteristics and how photovoltaic energy works. The main contribution of this work is the robust optimization of the photovoltaic electric vehicles powered with a triple-junction solar cell under different weather conditions and under parallel shade for different operation modes. For PV systems, several types of MPPT algorithms have been developed. The first suggested type of MPPT algorithm is intended for conventional MPP techniques. Offline MPP techniques and online MPP techniques are the two main subsets of the above approach. The current of fractional short circuit, fractional open circuit voltage, curve fitting, constant voltage, and ripple correlation control are particularly prevalent in offline. In online MPPT techniques, the perturbation and observation algorithm, scaling, and incremental inductance are the most commonly used. Importantly, this technology can improve the environmental conditions that have been generated by the transportation sector, also create a viable alternative. However, like all new technologies, there are concerns, among which is related to the cost, but according to research, the methods present have the benefits of lower cost on a simple structure, which facilitates implementation. Likewise, these approaches, MPPT offline, are the less accurate and only significantly employed in lower power applications where atmospheric conditions are stable. In addition, online MPPT techniques have a simple structure and the advantage of high reliability. Likewise, the author proposes to develop a robust MPPT controller, robust enough to generate power based on a first-order sliding mode approach for photovoltaic systems that fit electric vehicles, understanding that it allows to protect the functionality. The convergence of the PV generator powers to the maximum power points is demonstrated by a detailed stability analysis. The PV generator is based on a high efficiency triple-junction solar cell. Among the different considerations, it is proposed that they can face different operating conditions, including abrupt variations of the weather conditions and partial shading. The simulation results obtained with MATLAB and Simulink package, being these designs used as models, demonstrate the high performance of the proposed MPPT algorithm in energy optimization. Finally, and from critical perspective, I consider that the author proposes an environmentally friendly alternative which, considering the situations that the Earth is facing, such as climate change, the greenhouse effect, and the different consequences of these problems, proposes a successful solution. Bear in mind what was stated at the beginning, and is that much of the pollution and carbon emission is produced by the transport sector. Unlike any research, the author's proposal is focused on providing a solution to this. Then, proposing solar photovoltaic energy is nothing more than a tool to ensure the transport sector, offering consumers an alternative which, according to the results generated by the author of this article, is economical and does not alter the operation of the cars. Now, I consider that is a viable alternative and that it can give very good results, bearing in mind the results obtained in the pilot test, and that allows me to assure that it is an innovative and risky proposal which can change the environmental panorama that society faces and in some way demonstrate that the natural resources are impacting sources in the production of energy in the different environments of the human being, and that the social, technological, and civil development of the world can go hand in hand with nature, exploiting the memories that it offers us. Thank you.